In this video lesson, we'll be exploring the basic laws of Boolean algebra, which will be most helpful as you work on multiple choice questions dealing with Boolean logic. The worksheet that you'll be doing after this is entitled Boolean Logic Exercises, and questions like these are the most likely that you will see on the AP Computer Science exam in spring. Now, if you go to your website and you want to find this next document, on week 13, you'll see a link to Laws of Boolean Algebra. And when you choose that link, you will see this document right here. And this document goes through the basic laws of Boolean algebra. And that's what we're going to spend our time on right now. So we're going to start with some of the basics, and we'll go in more depth on some of them. And so we'll just start off at the top right here with, oops. Can't lose that. Okay. With A or A. Remember the plus sign means A. So if it's A or A, clearly it's A. If it's A and A, clearly it's still A. So the intersection of A is A and the union of A is A. Now we're down here on this row. A or B is the same as B or A. That makes sense. It doesn't actually matter the order when we're using or. Same thing for and. Commutative property holds true for both or and. Same thing with the associative property. It doesn't matter which ones I'm comparing first. So if I have A or B or C, I can check B or C first, or A or B first, and I'll get the same response. Same thing with and. The associative property applies here too. It doesn't matter which two I compare first, I will come up with the same answer. Now the first really interesting one is this one, and this is the distributive law for and over A. And we're going to explore this one a bit more, but you'll see if it's A and B or C, then we can rewrite it as A and B or A and C. And let's just explore the truth of that statement. So we're going to go here, and I've got this one here. One of the ways we can check to see if something is true is by making our truth table. So let's go ahead and set up our truth table. I've got A, B, C. You'll recall we do 4 trues and 4 falses. And then for B, we're going to go true, true, false, false, true, true, false, false, and then for C we just alternate true, false, true, false, true, false, and true, false. Okay, so what we're interested in is, let's see, A and B plus C. So let's first get B or C. So that's going to be this part. And B or C gives me true, 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 false, right here, true, 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 false. And now I'm going to compare that with A. So I'm going to get that left side. A and B or C. So remember, this is and this is or. So when I look at A and B or C, true and true gives me true, true and true gives me true, true and true gives me true, but the rest of these true and false gives me false, false and true is false, false and true is false, false and true is false, and lastly false and false is false. So I've now checked the left side, and then now I want to work on the right side. So I need these columns. So I need A and B, and I need A and C. And if I do A and B, I can see that it's going to be true in the first two, and I keep going down here, false on all the others. So true, true, and 6 falses. I think I'm missing 1, 2, 3, 4. Oh, they're all there. Okay. Then I can do A and C. When I compare A and C, I can see the first one is true and the third one is true, but all the others have a false in there. So first and third. And then we do our very last statement, which is to combine these. So we've got A and B or A and C, and I compare these, and since I'm working with or, as long as one of them is true, it's true. So I've got true, 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 because there's a true, both true here, one true here, one true here, and the rest we can see are all false. And we've just shown that this is true because if we compare our two columns. This one was the left side and this one was the right side. You can see both of them come out to 3 truths and 5 falses. Now, clearly you don't want to have to go through a truth table every time you see this. So if you recognize that it's a distribution of and over or, you know that they're going to be equivalent. Now, not only is that equivalent, oops, back over here. The same is true for distributing or over and, so it goes both ways. And we won't do the truth table on that one. You can do that on your own time if you're not sure about that. All right, let's look at this next one. The law of union. Remember, the number 1 means true. So if we say it's A or something true, well, with an or statement, as long as 1 is true, the whole thing is true. So with this true statement, it really doesn't matter what A is, the whole thing is true. Similarly, in our next one, if we have A and 0, that means A and something false. All you need is one false thing and the whole statement is false, so it doesn't matter what A is. All right, so the next one we're going to look at is this law of absorption. And that says that if I have basically an and an or and 2 A's showing up, it evaluates to the same thing as A. Let's explore that one. We're not going to make another truth table. We're actually going to use Venn diagrams to help us with this one. So when I'll start off with the easier of the Venn diagrams, which is the one that's just A. So I'm doing the right side first. So here's A, and I have colored in, there it is. That's A. All right, so now let's do this side, and we're going to do A and A plus B. So let's just consider A plus B. Remember, A plus B is going to be A or B. There it is. So that's A plus B. And then I want and A. Well, A is just A. And oh, okay. Well, the intersection of this first one, the second one, is this. So this is A and A or B. And we can see that they are equivalent. All right, now, not only is it if it's and then or, it works the other way as well. So on this next one, we could do A or A and B, and you're going to see the same thing because there's those 2 A's showing up. Law of absorption says it will be A. By the way, right now I should point out, while there are names for all of these, you will never be asked to come up with the name. So sometimes I'll refer to the name, but you'll never be quizzed on knowing the name of the laws. All right, we're on this next one. Here we have A and something true. Well, this thing is true, and so whatever A is going to determine what it is. Because if A is true, I've got true and true, which is what A was. If A is false, I have false and true, and I get evaluates to false, which is what A was. Related is this one, A or false. If A is true, then I have true or false, which comes out to be true. And if A is false, false or false comes out to false, which was also A. This one is super obvious to students. Not. We always like to talk about double negatives, like turning on your light switch and turning it back off. You end up right back where you started. So 2 nots takes you right back. And then let's take a look at this next one. This has all possibilities, A or not A. Well, if it's either A or it's not A, it's always going to evaluate to true because all we need is one of those to be true. And let's explore that just a little bit farther on this slide. The way this often comes out in a question might be something like this. We might say x greater than 10 or x less than or equal to 10. Now I want you to see that these are complete opposites. If this is A, this over here is not A. Now if this is true, then this is false. And if this is false, then this has to be true. And since it's an or statement, all I need is one true. It always evaluates to true every single time. And that's why we say it always equals 1. If we look at the next one, I'll just switch colors here. I've got same sort of idea where they're opposites. So let's keep with our x greater than 10. But now we have an and in between. And here we have x less than or equal to 10. If this is true, then this must be false. And I have a false here. So that means it's going to evaluate to false since I'm working with and. And if this one is false, then this one over here has to be true. and with and I have one false, and so that always gives me false. So no matter what, the answer is always false, and 0 represents false. All right, we're making great progress here. So we're down to our last ones, De Morgan's law. And De Morgan's law comes up frequently, and it's a really good one to know because it can save you a lot of time. So in De Morgan's law, it kind of looks like you're distributing a negative. The only thing is you'll notice that that not gets like distribution, but the or changes to an and. And down here, the and changes to an or. So if you, like math, distribute your not or your negative, it switches your ands and ors. And let's just explore that one. We'll do that with a Venn diagram. So in this first one, we're going to take a look at not A or B. Okay, so if you recall, A or B is the inside of all of this, but we want not that. So let me erase that, and it's going to be everything that that wasn't. So we've got everything out here. There we go. And on the other side, we're going to say not A and not B. So let's see, well, what's not A? Let me use some different colors. Not A is everything outside of A. And then not B is everything outside of B. All right, so everything outside of B. There we go. And now I'm looking for my red and green plaid. And where do I have my red and green plaid? Well, it's not inside either of these circles. It's everything out here. So let's just clean this up now that I can see actually where it is. Oh, close. I color it in, and lo and behold, it's the same as the previous one, where it's everything outside here, and we can see those are equal. So where we might see that in a problem with computer science is we might have something like not A greater than B, or let's see, B less than C. And when we distribute this, we might say not A greater than B, and this becomes and not B less than C. Or even cleaner, what's not A greater than B? That would be A less than or equal to B, and B greater than or equal to C. All right, good luck on the multiple choice associated with this assignment.